Okay, for this one it reads, test the hypothesis using the p-value approach. Be sure to verify the requirements of the test. I have a little instructor tip here. There's no need to use the table on these. We're just going to use StatCrunch and or the TI-84. And you are watching the homework help video for this, so let's close that out. Okay, so let's go ahead and start with the TI. Okay, so this problem doesn't have any context. We're just sort of putting numbers in, but let's sort of make sure we can read this. We have the null hypothesis. The proportion, the population proportion is 0.3 versus the alternative that it's greater than 0.3. And then we go out and collect some data, and we got 43 out of 125. I want to know how likely is that. So one thing I will often do is like, well, what is the sample proportion, the p-hat? So 43 divided by 125. So that's about 0.34. Right, 0.344. So if I'm looking at this, it doesn't look like that's very far away from 0.3, but I could be wrong. 34% versus 30%, sort of depends on the sample size. 125, it's going to be close. So let's go ahead and try this. So press Stat, scroll over to the test, and go to one prop z-test. We have one proportion that we found that this n is 125, x is 43. The other choice you would often have is two proportions. If you get more than that, you do something called a chi-square. So one proportion z-test. And our p sub naught, or p sub 0, is always this value here. Think about it as the null, the little sub 0 here in the null hypothesis. So 0.6, sorry, 0.3. Okay, we have our x, we collect some data, and 43 out of 125 and it says proportion is greater than. That's the alternative hypothesis. It'd be nice as soon as you put a number in here, it would pop down here, and that would sort of align more with what it looks like, but I think we're okay with that. You can draw it if you want. I'm just going to calculate it. And here's our p-value at, well, we got a lot of values here. Let's sort of unpack this. So the proportion is greater than 0.3. Here's our z statistic, and that's what we want for this first particular one. So round to 2 decimal places, so 1.07. Now, once the p-value, bring that back up. Here's our p-value. Notice here's our p-hat, our sample proportion, 0.3444. And there's our p-value, 0.14. We want 3 decimal places, so 0.142. Okay, and so our alpha level is set at 0.01. So we want to know if our p-value is lower than alpha. So that's a pretty high p-value. So this 0.34 that we obtained could have happened by random chance, even if this is still 0.3. So we don't reject the null hypothesis. It certainly could still be equal to 0.3. So do not reject because the p-value is greater than alpha. Now let's do this on StatCrunch. So question help and StatCrunch. Okay, so we're going to go to stat. It's not a t-stat, it's a proportion stat, and we just have one sample and we have summary data. So put in the number of successes. If you happen to have chosen the wrong one, you chose with the raw data, you would quickly see that we don't have the raw data. There's not enough inputs there. So number of successes we said was 43. That's our x. Number of observations, our n, is 125. And it says p equals 0.3. And we want this to be greater than. And then just press compute. And there we go. We exactly the same thing we obtained on the TI. A little bit easier here, in my opinion, on StatCrunch. But nonetheless, that's what we have. Hope that helps.